Yeah, go.
Yeah.
So it's at the bottom of the page.
So I always start by writing it. At least that. So then what I did first, I split this surd into, like by surd rules, and then I split it into root 3 over times by root 4. And then put that and then after that I simplified because this is actually. Can I extend the page?
You totally can. Wait, is that enough?
Yeah, that's fine. So then I wrote it as 2 3, subtract 1 over 2 minus 3. And then I rationalized the denominator. So since it's like this sequence, you do the opposite sign to split the difference of 2 squares. So you multiply the top and bottom by 2 plus 3. And that is basically 1. So then I got, I'm not going to bother writing the brackets because that is long. So I got 4 root 3 plus 2 times 3 subtract 2 subtract root 3. And then on the bottom, it just simplifies to 4 subtract 3, which was 1. So then I simplify further, and then we can see that equals 1.
Because 4 take away 3 was 1.
Oh. Plus 6 minus 2. So these are like terms, and so that gives us 3 root 3. And then 6 subtract 2 is plus 4, but since they want us to write it in the other order, just write 4 plus 3.
Lovely jubbly. Okay. Well, I was just going back up to show you that Leonie had done what they'd asked you to do. Okay. So the key thing that lots of you forgot to do in the, that's lovely, thank you, Leonie. The key thing that lots of you forgot to do in the mock exam was when you're rationalizing where it's more complicated. So if it's just root 3 on the bottom, then you would multiply by root 3 over root 3. But if it's an expression like this, then you multiply by what's called its conjugate, if you remember that word. And so where that was 2 minus root 3, you multiply by 2 plus root 3. And as Leonie said, that gets you the difference of 2 squares. Okay? Shall I just pause that while people finish? Well, maybe I'll just...
Okay, so we know 2 things. We know the volume, or expression of the volume, we know an expression for the surface area. So we can use our formula sheet to write this out as it states in the formula sheet. Right?
Yeah?
Yeah. Okay. So to find the surface area of the sphere, you do 4 plus 4 pi r squared. Divide that by 2 because you can see it's a whole sphere, and we also take into account this part because there's another circle surface area added on to the one of the sphere, you know. Yeah, and so if you do the surface area of a circle, which is
okay, so I'm just going to pause it there just so everyone understands that bit. Far, so great. Awesome.
Okay. And then this equals 63 pi, and we know this because we give you the surface area. Where do we go after this?
Should we simplify maybe?
Yeah.
I can give you more space, just FYI. Do you want to move? Oh, shush now. Anyway, I'll just move it down here.
Okay, so to simplify this, you can see 4 pi divided by 2, so you can just simplify that to what did I actually do? Yeah, 2 pi r squared plus r squared. And then you can make that. Okay.
Just go under. Oh my gosh.
Pi r squared equals 16 divided by 5. And from there, you can from there. Over. I love it.
I was just trying to indicate you could perhaps go underneath here, but you're good. You're good.
Okay. And then if you simplify this more, I think I'm spending too long simplifying this, but whatever. 16 divided by 3 pi over 3 pi. That's how my note says, it probably isn't right. Anyway, put in the calculator, it simplifies even more to 4 over 3, which is a good number.
Can I give you all a little bit of help here? So because you can look at that, because you've got 3 pi r squared equals 16 over 3 pi, because you've got a pi here and a pi here, secretly you can just ixnay out. Oh, shush now.
Compare it.
Yeah, you can just cross out both of those pi's. So you've got 3r squared equals 16 over 3. So that means that we could write then r squared equals 16 over 3 divided by 3, which is 16 over 9, which is, and the square root of that gives you the 4 over 3. But if you use your calc and you got that, then that's awesome. But just knowing that here, if you've got pi on both sides, you can just cross it out. That makes life a little bit easier sometimes. Yeah?
Yeah, is that the square root or just... Oh yeah, so we're going to see r squared here, so I was doing it in more weird and complicated way, which is unnecessary and not smart.
And secretly you need to square root the whole thing, Ace Girl.
Okay. Oh yeah, my note does say that. There you go. Okay. Very strong. So this we have found the radius. It's 4 divided by 3.
Okay, great. So far so good.
So now we can turn our attention to the volume. We have a formula for volume. It's...
Maybe write it underneath so we don't go over the top of something else.
Oh, right. Okay.
Maybe? Just...
So the expression for the volume, which we just calculated, is 4, 3, pi, r squared, cubed, sorry. And you divide that by 2 because once again it's a hemisphere. Now that we have that, we can say, oh, well, we know what r is because we worked it out with the surface area expression. So this equals... Wait, hold on. I don't know what I'm doing.
Yes, you do. You're fine.
Oh yeah, and then that equals this equals k pi, which we know because they gave it to us in the question. I think it's so long. Sorry.
No, you're totally fine. It is nice you're going at a good speed because I think everyone's keeping up with you.
It equals like.
It's more you're setting out that I'm amused at.
Okay. Can we go down?
Yes.
Now that we have this, we can simplify it or just put it in your calculator. Anyway, I just put it in my calculator. The finished expression is divided by 2, and then you divide all of this by pi.
But do they not want it in terms of a pi? It says k pi.
Yeah, it's a formula thing. Oh yeah. Yeah, but if you work out k, then you... Oh yeah, then you don't need to... Huh? I don't know. I know the right answer.
Oh yeah, so
Find the value of k.
yeah. Does it say find the value of k? So shut up, Miss Harrison. It's fine.
Alright. Cool. I put that in my calculator and I got... Yeah. That's fine.
Does that say 5802469?
Yeah. Or 6? I don't know.
It just looked like a 6. Emma has a question for you.
That's what it is. What?
No, you have to know that now.
I don't think you're doing that in like 10,000 years. Is that 2 pi r?
No, pi r squared.
And the circumference is the... Mia, is that a 0? Oh, okay.
Yeah, yeah. Okay, we're good? Sabrina, you're up. Go.
Scroll down.
Do you want me to make this a bit smaller?
Okay.
Is that better?
So the first thing you can do is, okay, so that's the thing, apparently.
So that's from that circle theorem sheet, isn't it?
Yeah. So that times that plus that times that.
Okay, so the very long bit,
So
YA.
y to a times xa is equal to c to a times b to a. Oh my god, not that far.
So that's just a rule that you need to know.
And then you just like put these into this equation. Like that, because I don't know.
Because you called BCX.
Wait, is it x sometimes?
No, it's x plus 9, you're right.
Oh, why is it? Oh, no, why? Oh, because it's c to a. So c to a is right through here. So it's this like.
So maybe you put X on your diagram, Sabrina, that helps. Excellent.
Okay.
Huh? I'll extend you, hang on.
Yeah.
Excellent, wonderful, thank you, madam.
Wait, right above that is.
Yeah, you're recording now. Go.
Okay, so the diagram shows parts of the curve with the equation of x is fx. The coordinates of the maximum point are 35. So write down the maximum point of the curve with you. Okay, so scroll down. So for this transformation, so this one shows that since it's a plus 3, I'm pretty sure it shifts to the left by 3, because that's just the rule. So that would change the x coordinate times 3 to 0, shifts by 3. So that's 0, 5, because the y coordinate stays the same.
Yep.
Okay, so for the next one, it is changing the y coordinate because it's affecting the whole function. So it's just multiplying by 2, so that's double. So it'll turn the 5 to a 10. Can you read that the same?
Yep.
Yeah.
Good.
Okay, and then for the last one, this one's so it's multiplying the x by 3. So since it's doing that, you divide the x by 3, but the y stays the same. So 3 divided by 3 is 1, and then the y is still 5. And then for the right equation.
Okay, so are you all happy with those? So the plus 3 in the bracket shifted it left 3, as Leonie said. So that went left. The 2 in front of the whole function just doubled the y coordinate. And then because the 3 was inside the bracket, it meant we divided the x value by 3. Okay, so that got us those numbers there. And then the last bit.
So if I have so it's the minus 1. I just said it shifts down by 4.
Yeah. So when you've got a number stuck on the very end, it shifts it up and down. And in this case, it's obviously going to go down by 4. No, it's only 1 mark, so we probably should be all right saying shifting it down by 4.
Okay, I got this right. Gabriel's gonna do it.
Oh, Gabriella, go.
Gabriella's coming.
Okay, go.
So, if you look at your formula sheet, this is what you see for volume of shape A. Volume of shape A is a cone, and that's the formula. Then after you plug everything next for calculating, oh no! It's okay, breathe. Just breathe.
But maybe don't sing.
Okay. And then, because shape A is a cone and a sphere, we're going to do this. We're going to like do this. And do this. So, Gabrielle. Yaman? Okay, look at shape A. If we look at shape A.
Do you want me to scroll up? See here?
Yes. So we're going to find.
So she's finding the total volume of shape A.
Just now, the thing I did, I found this.
Yeah.
The volume of the cone.
Yeah.
And now I'm finding the volume of the cone.
Lesbians?
So I'm going to divide by 2. So there's a half.
Yeah, but not the next question, but the question after that.
Sure. She's on a roll. What the heck? I need to, latch onto this.
It's just, there's only like 4 questions I actually did. I got right.
No.
Yeah. What did you get for that one?
Right, that's it. Okay, we're all paying attention to what Gabrielle's doing, aren't we?
Yep. And then we're going to add these 2 together.
Oh God, I've got a Mia-esque now.
If we add this together, we're going to get a very long number.
Oh, that noise is so annoying.
Yes. And you're like, no, for the second. For the lower. Yeah.
You two, shut up. Sheila, you were one of the 2.
She's trying to let's
Make a girl like no, it was ice cream. It'd be like this big.
Right, okay, so Gabrielle's now done the total volume of shape A. Now,
That should be equals. Because in the thing it says volume of shape A equals a volume of shape B. Therefore, pi r squared equals everyone with me? Yes. And then we're going to divide this by pi. Therefore, we get. Make sure you don't lose any zeros. Matt? If we see this,
shh,
the
go.
height is 2r. So if you go down, you can pull the height.
Do you want me to do it?
The height is just 2r.
Oh, hello, what's happened?
And still have. And then.
So how do we simplify 2r multiplied by r squared? Nice.
And then. R. Yeah.
Twas Björn's. Ready? Any of you have questions for teacher Gabrielle?
Wait, no, I'm still.
Let's go.
Okay, so we didn't know Nutella. No. This is really not one. That's okay.
Why can we use SOHCAHTOA here?
Right. We're looking for an angle and we have two images.
But more specifically, why can you do SOHCAHTOA and not just sine or cosine?
This.
Yeah. Okay.
Okay.
What do you want to do?
You. Okay, so then because we have got an angle opposite to this is the O.
Oh, that's...
This is the H. Because this is H, and this is the O, and this would be A, and because we have A and H, this would be what just happened?
We're using cos.
We're using ka. So ka. So
Yes.
so we've got ka.
What is the issue?
Just come over here and ask.
So ka.
What is this
Sure, everyone
for?
can do it.
Never know.
Okay. Cos.
That's for the sum of the interior angles of a polygon.
Divide it by 10.
Well, if it's regular.
0. And I get your answer of 5,
I don't know what this is.
6.1 out 9.
Oh yeah, I just didn't read the question.
And then you round it.
No, you're right. You're right.
It's 5, 6, 9.
I just didn't read that.
Oh, wait.
Saracen, what's the formula for the sum of the interior angles n minus 2 times 180? Right, there's a part B.
Okay, so you've got a bearing. How did I do that?
Okay. Shh. Come on, girls. Let's just pay attention. Emma, darling, what are you doing? I've just moved it so you can see the question.
Okay, so we've got a bearing B to A. So we've got our triangle. A squared. And then I did 180 bracket minus 0.9 plus 9.
Wait, you're so this
What's in the left corner? Which equals 33.1. 33.
Darling, did you check that these are correct?
Yeah, I did.
Well, 33 is not a bearing.
This is 33.
Okay.
36.9, 300.
All right. May I possibly just get rid of all of this stuff?
I wrote it down.
No, I'm not saying this is wrong. It's just a right mess.
Drew a triangle.
So Emma's found this angle here to be 56.9. What have they asked for? They've asked, girls, please. They've asked for the bearing of B from A. So remember, bearings are measured in what direction? North, from north in a clockwise direction. So it's of B from A. So they want to know this bearing.
Oh shoot, I subtracted it from the wrong direction. Never mind. Oh, actually, no.
And so we know that this angle here is 90, yes? And so we're going to just do 90 subtract 56.9. Okay, so you had the correct answer, Emma, just totally, I don't know where you got your working from.
Yeah? So 90.
Okay? So, an angle, a bearing is measured from north in a clockwise direction. So if they want the bearing of B from A, remember wherever it's from is where you draw your north line. So that goes up here. So they want to know this angle here.
So it'd be 90 minus.
And so because we know this is 90, it's going to be 90 whatever this was.
Why is it of
Now, pardon?
I know what it is. Of B.
It's a bearing, you don't normally say, it's a bearing of something from something else. So that's always what you say.
But what about of B makes it that?
Because it's going from A to B. It's a bearing of B from A. So you always have a bearing of a letter. So if I wanted the bearing of this from here, it would be 90.
So what's any minus 56?
I'm sorry, pardon?
Like what the answer is?
So it's 033.1, whatever she had. So an angle, a bearing has to be 3 digits, so it has to have the 0 in front.
Wait, I don't understand what the working out was.
So ignore her working out, because this is a load of rubbish. Because what Emma found was actually this angle here, which happens to be the same as this one, but that's just because these two lines are parallel.
Oh.
So all you have to do is 90 subtract 56.9. But they want it to the nearest degree, so that's why it was 033, not 033.1. Okay? So if you're not sure about that, you can ask me about that after. Now you can carry on.
If it's just 1, 0, then you would subtract. We put the lower bound to -5. So that equals. Same thing with the up. Emma, try.
Okay, so that's just a straightforward one because that was rounded to 2 sig fig. So we've given our answer to 3 sig fig. Okay?
I can do this one here.
Right, okay. Shh. Let's go, Leonie.
Okay. So this is a regular 10-sided polygon. So just to address this, regular means all the sides are equal, and then you know it has 10 angles because it's 10 sides. So I started by finding the formula for all of the sum of all the interior angles. So the formula for that is n minus 2 multiplied by 1/8. And n equals the number of sides. So in this case it's 10. So 10 is 2 multiplied by 180. And that gives us 1,440. And then since we know that it's 10-sided shape, so that means it has 10 angles, all of it, we divide the total by 10, and then we get 144. So therefore we know that this equals 144. Yeah, all of them equal 144. And then this one also equals 144. So and where did I go from there? Oh yeah. Okay, so they're all yeah, they all equal 144. But I use these ones in my working. So since these sides are equal, since you know it's a regular polygon, you know these are isosceles triangles. So if this angle is 144, and then now angles in a triangle add up to 180. So I did 180. Ooh, okay. Subtract 144, and then I got 36. 36. And then to find what these are, these little angles right there, I divided by 2 since the base angles and an isosceles triangle are equal. And I got 18. Are you guys following so far?
Wait, what did you
I
do
am.
on 80 and 44?
Okay, so we found the sum of all the interior angles. So that's 1,440. And then to find each individual angle, we divided by 10, because there are 10 angles in the shape. And then we got 144. So we know that this angle is 144, and since it's a regular polygon, these lengths are equal, so it's an isosceles triangle. So that means that these angles are equal. So we know that's 144. We subtract that from 180, and then we have our result. Because we have to split it.
Oh, I remember that.
Yeah.
Okay, I'm just gonna. Okay, you good?
Yes. So then, different color now. So we know that these smaller angles are equal to 18. So these will both be 18. And then we just, since you know this whole thing is 144, we do 144 subtract 18. And subtract 18 again to find what x would be. And then I have x equals 183.
Lovely, thank you. Did you do the 4 with the same as Sabri's place that she learnt her 4s? What is it with you lot and your 4s? You do weird 4s.
I wrote them, okay, I usually write my 4s like this, but I don't know why I wrote it. There you go.
I'm getting really. Okay, ready? Go.
Oh my god,
So for A, it's 79 because this is 79. Okay. This part is 79, so that means that this is 79 as well.
Alternate segment theorem. Bless you. Alternate segment theorem.
That is 79. Yeah. And then
Perhaps draw the whole triangle in, Sabri. Like, you just go over this big triangle here.
so
That's it.
that means this one, the E79, because it's the same as this one.
DEB, yeah, is the same as DBA because they're alternate segments. That windsurfer one that I talked about. Okay, that's Tresbian, so that's that one. Oh, now we want BOE.
So for that one, because it's angles on a straight line equal 180, it would be 180 minus 79, which is 101. So that means that this whole section is 105 degrees, and you're trying to find this one. Here.
You're trying to find O.
You're trying to find, yeah, you're trying to find O. So you have that, so that is 101. And then you find this part, find this part, find that part. No, wait, no.
You don't
No,
have
you're
to.
wrong. Wait. Okay, no. Ignore me. That was completely wrong.
Oh, you can pretend it's a...
You could look at the big triangle, remember?
Yeah. So this is 79, and this is 79, which means that
No, you were going right to start with. You were doing well, telling me that this was 101.
You don't want to do it, I know.
But remember, you can think about this big triangle here.
Oh yeah, that's what I did. Oh, that's what I did. Okay, that makes sense. So 180 minus 101 minus 41 to find that.
You're doing good, Sabri.
Yeah, this is right. You're doing well.
Go, Sabri.
79 minus 41 is 38.
Okay, so
38. And then this is double that, so it's 76.
yeah, perfect.
Yeah.
Okay.
Well done, thank you. So remember, for the circle theorem, sometimes you need to kind of ignore some lines and look for triangles where you can. To try and make your life as easy as possible. So as I say, we completely ignored all these bits in the middle to try and find the 38, which enabled us to then find this one here. Lovely jubbly. Okay. Oh, is that last one? Great. Let's go, because we're like quite we're long. Right. So AB is 3, 2, and AC. Oh, we've got find this column vector BC. So AC. Oh no, that's not AC. AB. Yeah, no, that's AB, and then AC. So if we want BC, we're going to have to go down this way, yes, and then up that way. You good with that?
Yeah.
So I'm going to do minus AB. I haven't got me to help me now.
Okay,
So I've got minus 3, 2 plus 4, negative 1. Do you see that? So that's negative 3 plus 4 is usually 1, and negative 2 plus negative 1 is negative 3. Okay, so that's that column vector. Yeah, thanks. Right, so I was told that CD is 2 lots of AC. Well, they told me AC is 4, negative 1. That means that CD must be 8, negative 2. Okay?
Wait. Why?
It's just double it. 2 lots.
Oh.
Did you resist that?
I was looking at the wrong one.
Right, so it says find length of CE. CE. Oh, we just found BC. Close your hands, yes? So, to get from, what do they want, CE or EC? Say it in raise. So, if we want to find vector CE, then we have to go along here and up here, yes? So that's going to be 8, negative 2, it's not in the right place, plus, and then DE is the opposite of BC, yes? And we just found BC to be 1, negative 3, so it's going to be negative 1, positive 3. Yeah?
Yeah. What?
So we went up 8, negative 2, correct direction, and then this DE is negative of BC. So that's negative of 1, negative 3, which gives us negative 1 and 3. So that gives me 7, oh, not over, don't do that. So that's 7, 1. So if I've got the vector 7, 1 and I need to find the length of it, what do I do now? Whose rule do I use?
Pythagoras.
Pythagoras. So that's going to be 7 squared plus 1 squared. So that's 49 plus 1. So that's root 50, whatever that is, 2p.
Yay.
I don't know what that is. Because there's no extra 7 on it.
I just got lost. Yeah, me too.
Is it 7 over 1? Is it
lost?
That's a vector.
Okay,
And then they want the length of that.
Negative BC.
So this is my vector, 7, 1. Go, but they want the negative mix. Then the
Okay.
Right, okay.